Planet Earth is a place of constant motion. Beneath our feet, massive plates shift and collide, shaping continents. Above us, the atmosphere churns, bringing wind, rain, and sunshine. These dynamic systems are interconnected. They work together to create the conditions that make life possible. Understanding these systems is crucial for understanding our planet. They govern everything from our weather patterns to the distribution of life in the oceans. By studying these systems, we gain a deeper appreciation for the delicate balance that sustains life on Earth. The Earth's systems are complex and constantly interacting. Volcanoes erupt, spewing gases into the atmosphere. Ocean currents transport heat around the globe. The atmosphere itself acts like a blanket, trapping heat from the sun. All of these processes influence our climate. The atmosphere is a thin layer of gases surrounding our planet. It acts like a giant greenhouse, trapping heat from the sun and keeping Earth warm enough for life to thrive. This natural process is essential for our survival. Within the atmosphere, certain gases, known as greenhouse gases, play a particularly important role. Carbon dioxide, methane, and water vapor are some of the most important greenhouse gases. These gases trap heat and regulate Earth's temperature. Human activities, particularly the burning of fossil fuels, release large amounts of greenhouse gases into the atmosphere. This excess disrupts the natural balance and leads to a gradual warming of the planet. Understanding the role of greenhouse gases is essential for addressing the challenges of climate change. The oceans are not just vast bodies of water. They are teeming with life and play a vital role in regulating Earth's climate. Covering over 70% of the Earth's surface, oceans act as massive heat sinks, absorbing vast amounts of solar radiation. Ocean currents, driven by wind and differences in water density, act like giant conveyor belts. They distribute heat from the tropics towards the poles, moderating global temperatures. Crucially, oceans are also major carbon sinks. They absorb significant amounts of carbon dioxide from the atmosphere, mitigating the impact of human emissions. However, as the concentration of carbon dioxide in the atmosphere increases, the oceans are absorbing more than they can handle. This leads to a phenomenon known as ocean acidification, which poses a serious threat to marine ecosystems. When mountains roar, volcanoes and climate. Volcanic eruptions, though often perceived as destructive events, are a testament to Earth's dynamic nature. They also play a significant role in influencing our climate. They eject massive amounts of ash and gases into the atmosphere, including sulfur dioxide. Sulfur dioxide, once in the stratosphere, transforms into tiny sulfate aerosols. These aerosols act like tiny mirrors, reflecting sunlight back into space and causing a cooling effect on the planet. The 1991 eruption of Mount Pinatubo in the Philippines is a prime example. This powerful eruption released millions of tons of sulfur dioxide into the atmosphere. The result was a noticeable drop in global temperatures for the following few years. Studying such events helps us understand the complex interplay between volcanic activity and change. The seasons breathe. As the Earth revolves around the Sun, different parts of the globe receive varying amounts of sunlight throughout the year. This leads to the distinct seasons we experience. These seasonal changes have a direct impact on the concentration of carbon dioxide in the atmosphere. During spring and summer, plants thrive in the abundance of sunlight. Through photosynthesis, they absorb carbon dioxide from the atmosphere, incorporating it into their tissues. This leads to a noticeable dip in atmospheric carbon dioxide levels. However, during autumn and winter, plant growth slows down and decomposition rates increase. This releases more carbon dioxide back into the atmosphere, causing a seasonal peak in its concentration. Understanding these natural fluctuations is crucial for accurately interpreting the long-term trends in atmospheric carbon dioxide levels. Charting the future. Climate models and our role. Scientists use sophisticated computer models to simulate Earth's climate system. By inputting data on various factors such as greenhouse gas emissions, volcanic activity, and solar radiation, these models can project future climate scenarios. Current models overwhelmingly indicate a continued warming trend in the coming decades. This warming will likely lead to more frequent and intense heat waves, rising sea levels, and more extreme weather events. These changes pose significant challenges to human societies and ecosystems worldwide. Understanding these future projections is not about predicting doom, it's about empowering ourselves with knowledge. By understanding the science of climate change and supporting further research, we can make informed decisions. Through collective action, from reducing our own carbon footprints to advocating for sustainable policies, we can mitigate the impacts of climate change and build a more sustainable future for generations to come.